we continue to learn about ratios. For example, we always start with a word problem. For example, John and Peter have money. Of course, we like to talk about coins. In this case, they have quarters. So John has 8 quarters and Peter has 12 Q for quarters. The ratio, we say, the ratio of John's to Peter's is 8 to 12. Let me highlight the ratio of John to Peter's. The ratio of John's to Peter's, because we're going to look at 3 different points of views. The ratio of John's money to Peter's money is 8 to 12. Yes, of course, we learned how to say that. This is John's money and this is Peter's money. If we group their money, 8 and 12 respectively, into groups of 2, we can equally say that John has John has 4 groups of quarters and Peter has 6 groups of quarters. So we can also say that the ratio of John's to Peter's quarters is 4 to 6. And finally, we can group those coins into larger groups and combine them into 2 groups. So this is 2 groups of quarters for John, and this is 3 groups of quarters for Peter. And we again can say that the ratio of John's to Peter's money, J to P, is 2 to 3. My friends, to say 2 to 3, and to say 4 to 6, and to say the relationship or the comparison of 8 to 12 is basically to say the same thing. That's why we call these ratios equivalent. Take a look, very similar to fractions. Very similar to fractions. From 8 quarters, we reduce them to 4 groups, we reduce them to 2 groups, and for 12 quarters, these are Peter's money, we reduced Peter's money to 6 groups, and then further reduce them to 3. We can divide ratios the same way we divide fractions, except what we do to the left, we must do to the right. Let's continue exploring equivalency and, of course, simplest form. We should recall simplest form from our fraction days. Simplest form. Okay, let's start. Express each ratio in its simplest form. 4 to 10 is equivalent. Well, let's think about it. 4 and 10 are both even numbers. Therefore, they're both divisible by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Therefore, we can say 4 to 10 is equivalent to 2 to 5. Next example, 12 to 18. Well, let's think about it. How can we reduce 12 and 18 both using the same divisor? Or we also call it common factor, right? Common factor, the number we divide by. Well, 12 and 18 are definitely even numbers. That's good. But they're also divisible by 6. Again, what we do to the left, divide by 6, we must do to the right, divide by 6, and 12 to 18 is equivalent to 2 to 3. Let's go. Express each ratio in the simplest form. I'm only going to do one box. I'm only going to do B and D. Okay? So 10 to 6. I hope you all remember how to reduce numbers by the common factor, by the common divisor. 10 and 6 are both divisible by 2. So we get 5 to 3. 21 and 14. Let's think. Of course, hopefully you guys see that both of these can be divisible by 7. Let's reduce those numbers. So we arrive 3 to 7. This is what we call simplest form. These two numbers, 5 and 3, can no longer be divided by anything other than 1, and 3 and 7 can no longer be divided further other than by 1. There are 15 dogs and 12 chickens. I'm on the next problem. 15, D for dogs, CH for chickens on the farm. Find the ratio of the number of dogs to chickens. Well, 15 to 12, that's definitely what we have. But if we reduce it further, right, both 15 and 12 are divisible by 3. What we do to the left, we must do to the right. So 15 divided by 3 reduces to 5, and 12 divided by 3 reduces to 4. So to say 15 to 12, we can say for every 5 ducks, there are 4 chickens on the farm. 5 to 4. The ratio of the number of ducks to chickens can be expressed as 5 to 4, and that's our simplest form. Next problem. There are 40 students in the class. Of course, 21 of them are boys, and the number of girls we can find using step 1, of course, by subtraction. So 15 girls and 25 boys, right? Now, find the ratio of the number of boys to girls. They're looking for boys to girls. Remember, I always like to write down my letters, what we're comparing with what, so I don't mix up the numbers. The number of boys to the number of girls is 25 to 15, which we can further reduce. 25 and 15 can be further reduced by the common factor of 5. Divide by 5. Divide by 5, so it's 5 to 3. We can say that the ratio number of boys to girls is 5 to 3. That is to say, for each of the 5 boys, there are 3 girls in the class. Next, we're comparing ribbons. We have ribbon A and its length, and we have ribbon B. And of course, as it's shown, the ribbons are not equal. We know that it is given that the length of ribbon B to ribbon A is 7 to 4. My friends, Singapore bar models to the rescue. I like to label my bar models. Bar models are those rectangles that are split into equal parts, into equal units. So we have for ribbon A, we allocated 7 units, and for ribbon B, we allocated 4 units. Why? It is given by the problem. It is also given that ribbon A is 21 meters long. The most important question you need to realize, if 7 units is 21 meters, that means each of these units has 3 meters, 3 meters long, 3 meters long, 3 meters long. And I like to label at first almost every one of them just to kind of visualize that each of these units has 3 meters in it. How did we get there? Well, it's 21 divided into 7 equal parts equals 3 meters inside each. Therefore, the question is asking, find the length of ribbon B. Okay, well, ribbon B is 4 units. 3 taken 4 times gives us 12 meters. 1 unit is 3, therefore 4 units is 12. It's 3 taken 4 times. The ribbon B is 12 meters long. I hope you found this video useful. We will solve more word problems in the next video.